This is explained as a transconductance amplifier, which maps input voltage not to an output voltage, but rather to an output current. So its gain is a ratio of I out to V in, and that has units. It's not dimensionless like our usual ones. So the first question is it an inverting or a non-inverting amplifier? And it sure looks like an inverting amplifier. After all, we've got the input going into the inverting input of the op amp, and the non-inverting input of the op amp is grounded. That looks like our usual inverting amp. So I'm going to write that, but I'm a little suspicious, and I'm going to come back to this too. Make sure that the gain is negative, which is what it really means to be an inverting amplifier. More positive input mapping to more negative output, that would be an inverting amplifier. We'll come back to that. When it is operating as intended, what is the voltage at point A here? Well, if the op amp is a happy op amp, if it's succeeded in matching its inverting and non-inverting inputs, then since this one is definitely 0 volts, this one had better be 0 volts too. So that's true of any happy op amp. For which input voltages can it operate correctly? We better take a good look at how this operates. So what can happen here? What the op amp's output can do is it can put a current from base to emitter on that NPN transistor. And if it does that, it's going to allow a current to come down through the load in the direction that this definition of I out here considers to be a positive direction. So that's what it can do. If it does that, that same current that's going through the load is also going to go through this resistor, through the 33 ohm resistor, and create a positive voltage here. The positive current times this 33 ohms gives you a positive voltage here. That's all it can do. It can't make this point negative. It can only make it positive. So remember that the sum of the currents at this very important critical point here, the currents there have to add to 0, as they do at any node, but in particular for when it's connected to an op amp input, you know that no current flows into the op amp, and so the sum of the current in this branch and in this branch have to add to 0. So let's imagine for a moment that this voltage is positive 10 millivolts, positive a few millivolts, whatever. That means that a current would be flowing left to right, and in order to have the node add up to 0 current would have to be flowing this way. From a 0, it's only going to flow this way if this point is negative, and that can't happen. Okay, so that's one way of looking at it. Let's just analyze the operation of the circuit. I'm going to put a voltage V here, and I'll call that V in. It is called V in. And that means that the current in this branch here is V in over 1,000. So that has to add up with the current that's coming to that would be coming in this direction. So that is going to be, I'll call this VE for a moment. That current, V in over 1K plus VE over 5K, that has to add to 0. The sum of the currents has to add to 0. And you can see here that because VE can only be a positive number, V in has got to be a negative number. So this is only going to operate correctly when the input signal is negative. Or is that negative? What's the input impedance of this amplifier? Well, here's a 1K resistor, and this is a virtual ground, so a good guess for the input impedance is 1K. And finally, most importantly, what's the gain of the amplifier? So here's an equation that just is the node equation for this point. VE over 5,000. What's the relation between I out and VE? That's very straightforward. The current here is VE over 33, and so the current up here has to be VE over 33 also. Okay, so we have an equation now, V in over 1K plus, this is I out, 33 times I out divided by 5K equals 0. And we can solve that and find that the gain is negative 0.15 amps per volt. So that goes in here, negative 0.15 amps per volt. And we're happy to see that it is indeed a negative gain, justifying that guess that it's an inverting amplifier.